Welcome to week 3. We're going to talk about manufacturing processes and layout this week. In this first video, we're going to look at some of the concept side of the material and look at how the decisions basically can move between different types of manufacturing processes and why you would select one type over another, explain how those processes are different to support different contextual environments that a company might have. And some of the, to allude to what we're going to look at, it's really the volume that we manufacture in and the level of uniqueness of the work. Okay, so we'll go from very standardized high volume type production, and we'll look in the middle at batch type production and so forth. And then we'll look at job shops and unique one-off type things like a body shop would do, for example. Okay, we'll also look at the critical role that customization has when we do layout decisions. So how customized is the product, and where in the supply chain is the point of customization? And you'll understand then why it's very important to have those things very clear before we take decisions on what we're going to do with manufacturing, where we're going to build a plant, the capacity we need, how the lines are going to operate, and so forth. Okay, so let's move along. So the manufacturing and service processes are very important to firms, and getting the decisions right is very important. For one reason, because the investments in these things are long-reaching, and so we don't turn on a dime with these things, right? We build a plant; it could take years to build a plant, and by the time that we've finished all the decisions on what type of equipment we're going to use, what kind of people we need to hire and train, and what kind of volumes we can commit to from customers, and what our supply chain looks like, and so forth. There's implications to all of these things, and the fact that we can't just do a redo because of the financial money that's really taken up by these decisions means we have to be very careful. So different processes have different strengths and weaknesses, and we'll look at some of those here as we flip through the next slides. Some processes are good at supporting a wide variety of products and are very flexible at high volumes or at low volumes, and others are really optimized to give standardized production of standardized parts at high volume and very low cost. So managers have to make sure that we pick the right ones. We have to understand it. The more we know, the better choices we're going to make. So some of the questions that firms ask when they're looking at a manufacturing process: so what are the physical requirements of the product? Are we building airplanes, or are we building toasters? You know, what is the actual physical size of what we're trying to get done here? And how similar is the product to other products that we make here, and to it within a family of product, or even extended beyond the family of product? So how much similarity do we have, and what are the production volumes? And high volume to one company is low volume to another. So volumes are relative, but what are the volumes? What are the actual numbers? How many do we need to build? And where the value chain does this customization take place, if we have customization? So there are two basic layouts that you should understand as part of this module. So one is a product-based layout, and that's where all the resources that it's required to build this product are arranged sequentially according to the steps to make a product. You could think of an automotive assembly line. You could think of the video that we had with a Dell computer, where it's going through an assembly process. Even though it's mass customized, it's still an assembly process, sequenced out. Or in a functional area, you could see where different things are grouped by a particular function. So in a plant that has plant within a plant type functionality, maybe we would do all of our electronic circuit board assembly in one area of the plant, and that would be a functional layout. And maybe we would build glass panels and seal those in one certain area of the plant, or extrude aluminum where the extrusion machines are. but then cut that to length and move to another area of the plant to do fabrication of cutting and bending on those parts. That would be a functional layout. A lot of times plants don't exist in one or the other of these, and it's actually an intelligent hybrid, like so many things in this course, where we look at black and we look at white, and then we say, well, the way firms actually exist is in some blend of the two. And you'll see that if you do a tour of a manufacturing facility, you will see signs almost certainly of product-based layouts and functional layouts in different parts of their process. So the 5 areas that you need to be familiar with, and we'll walk through each one of them with its own slide, are these continuous flow processes that run uninterrupted, production lines that run almost uninterrupted, but that do change over and so forth, but still run in a continuous flow type of process. The batch manufacturing, which is really a hybrid between job shops and production, where we have a sequence of things that happen, but we do some of those in batches. You could go back to the example I mentioned a minute ago where I said we extrude some aluminum over here and we run batches of different extrusion lengths. Maybe they're for your shower door, for a shower door manufacturer. And then those lengths go and they get cut to a certain length and maybe formed and bent and buffed in another batch of the plant. So it's an assembly process that's sequential, but it's done in batches in different areas of the plant. We'll look at job shops, which are much more unique and low volume, and then talk about fixed position layout. So the first of those, the continuous flow, this is a type of manufacturing process that gives highly standardized products, and that is in an uninterrupted, we'll say, hypothetically uninterrupted sequence of steps. So it's very closely resembles the production line process, except that it is not broken into any steps whatsoever. And probably the best examples of that are things like yarn, where you think of something just coming off a spool. Food products, how do you think all those jars get filled, right? In a continuous flow. The jars come under the machine and we just keep doing the same thing over and over. Filling tubes of toothpaste, filling jars of spaghetti sauce. Chemical products such as oil and gas, those flow and flow continuously. So they're a good example of continuous flow. Production line is a type of process used to produce a narrow range of standard items. Automotive assembly plants are a great example of this. But basically, it follows a product-based layout. It's a sequential steps. They're usually linked by some system that moves items from one step to the next, an assembly line or other type of process. They're suitable for high-volume production of products, usually with similar design attributes. So there could be a flexible system running on an assembly line, but these would have somewhat still similar attributes because the complexity of doing customization, really true high customization, doesn't lend itself to a production line. You need high volumes to justify huge investments in a major production line. And they're somewhat inflexible. They change from time to time, but think of a model changeover for an automotive plant as the level of flexibility. The parts that are coming in are highly standardized. They fit together in a certain highly engineered way. We can't randomly play with that. We can have plug-and-play components that allow us some variety in that process, but it's fairly it's really a fixed and highly engineered designs. The third one is batch manufacturing. So I mentioned earlier that this fits somewhere in between a job shop and a production line, in that it gives a bit of the best of both worlds. It allows higher volumes and some level of standardization in what's being done, but it also allows the quick changeovers and the flexibility of a job shop. So for many companies, if they have a variety of customers and they want to build in a sequence, but it requires different functional areas of the plant to do different processes, And we could go back to that aluminum plant where we want to extrude aluminum in one area. This is huge equipment, just continuously kicking out an extrusion. And then we want to maybe cut those extrusions down to length because they come out, say, 60 feet long or more. Cut those down to a certain length for a shower door and machine them a little bit with some screw holes and stuff in one area of the plant, doing small batches, and then move that over to be anodized in another very capital intensive area of the plant. So batch allows that company to achieve economies of scale and have a level of specialization, but also to be flexible in their production in saying, we need to run another 3 batches of this part, and then we're going to switch over and use all of this equipment or a lot of this equipment to carry over to run another product for another company. So it has its place. There is a higher inventory cost due to a work in process inherently when we do batches, and the sequence of steps is not as tightly linked as a production line flow. Flexible manufacturing systems using highly automated batch processes are something that firms, if they're willing to make the investment, find even better economies of scale in batch manufacturing. A few examples of batch includes books and newspapers, whether we run for the day or run for the certain book run and then switch all those assets over to run something else. Pharmaceutical, where the same equipment with proper cleaning and switchovers can produce one compound one day and another the next day, or a baker making a batch of cookies and next comes a batch of pies, right? Job shops are what we think of as little custom shops that we deal with. Usually they're small businesses in most cases, broadly skilled workers. So if you went into a body shop, you might find people that knew how to work in the paint booth, but also know how to do welding or finishing of sheet metal components and so forth. So cross-training is real common in a job shop. The main emphasis is meeting the unique requirements of this job, whatever needs to be done, right? Meet those unique requirements. So some more craftsmanship and journeyman and skilled labor. Product design is not standardized, and typically they follow a functional layout, not a sequential production type layout. So manufacturing processes can also be a fixed position layout, and this is worth understanding. It's interesting when you think of it. So fixed position layout is a type of manufacturing where the position of the product is fixed. And you can think of examples. I'll give you a few and you'll immediately grasp it, such as shipbuilding. We're not going to move the ship through the process. The process is going to come to the ship. Huge construction projects, a bridge, a building, and so forth, and building a traditional home, even a small home. The work comes to the project. So fixed position. Materials, equipment, and workers are transported to and from the product, and it's used in industries where the products are bulky, massive, heavy, and movement is problematic. So there are also those are the kind of the big 5, but there's a lot of hybrid that goes on as well. So it's when we try to combine a few characteristics of one of those 5 with characteristics of, one or 2 others or 3 others, whatever it might be. Business and running operations is all about optimization. So there's no rules that we can't break to say what are the best tools we can use, in our case, to solve at the micro level what we need to accomplish instead of just looking at the macro high level. So machining centers, and you could think of doing several steps of a process all at once. So if you took a piece of metal and you needed to do different forms of that metal, remove materials in different ways, you might put it into a 5-axis milling machine, which are very expensive, and let multiple cuts happen to that material all at once. And that would be a machining center. Group technologies basically is where we bring together an expertise, inside of our manufacturing and say, right in this area, we're going to do all of our, whatever it is, our welding, our glass builds, our electronic subassembly, our anodize and so forth. So Group Technology says we can use this dedicated focused center to accomplish things for multiple products, multiple assembly lines, and all of the product will come here to this focused Group Technology Center. Flexible manufacturing systems, those are highly automated batch processes that can move between different products. And again, that's if the firm finds it makes sense economically to invest considerable systems in because when we want to run high speed and we want to run flexible, it brings a lot of cost with it. This is what's known as the product process matrix, and it's in virtually every operations textbook that I've ever seen. And it's simply saying that if we look along one axis, we can see that continuum of the different processes we just discussed, and say a job shop being very low volume and highly specialized, and production line being suited to high volume and low levels of specialization and flexibility. And we could see over here that we can match them up, right? Those if this is our product and this is our process, well, if we want high production volumes and highly standardized products, that we've got a mismatch here with job shops. We've got a gray zone here with low volume and high volume batch, and we've got a mismatch with over here with the one-off type products that can't work on a production line. So, this is the zone that we can work in the product process matrix. Job shops most easily working with one-off, but possibly working in small to medium production runs. High volume batch not being compatible at all with job shops, but possibly with small to medium production runs, and possibly with either of these other two, getting all the way up to high volumes and highly standardized products with a high volume batch type production. And production lines really only being compatible with medium to large production volumes and high production, highly standardized. So that's a picture that speaks 1,000 words, and you should be familiar with this, of course, for the exam, because there will be some questions about all these concepts. And if you understand this production process matrix, you probably will have the concepts pretty well figured out for the exam. So now the other part of this discussion, we're going to talk about customization. There are 4 levels of customization that you need to understand for this course, and they run in a kind of a continuum, okay, like we did with volumes and so forth in the other discussion, the prior discussion. So the customization levels are from highly standardized, make to stock, MTS, and these are products that really have no customization. We build them to a certain specification, and they are what they are. A couple of examples could be a hammer or a toothpaste. That doesn't mean we can't find different kinds of toothpaste or hammers. It means they're not coming off the same assembly line generally. They're coming off different assembly lines. Assemble to order, ATO, are products that are customized only at the very end of the manufacturing process. So a good example of that could be a sports logoed shirt. So we've built the shirt, we've dyed the shirt, and it needs to get a logo sewn onto it, and we don't know whose logo it's going to be. Maybe it's this country club or that country club for a nice golf shirt, right? And maybe for a t-shirt, it hasn't been dyed yet because it's going off to universities to get sports logos put on it and a certain color combination laid into it. But that's assemble to order. That's where we built a standard part, a t-shirt, a white t-shirt in 3, 4, 5 different sizes, and sent those blank t-shirts on to its final assemble to order type process where this t-shirt customizer will give it its identity. Make to order products are closer towards customization in that they use standard components, but the final configuration of those is customer specific. And because we've been talking about it in the class and we're getting familiar with it, I will again use Dell as an example of that. So it's using standard components, plug and play components, highly engineered, not ad hoc decision of what's coming together on that line, but it's configured to the customer's specification and order. The most customized, let's go back one. The most customized is the engineer to order, or ETO. And this is where products are designed and produced from the start to meet unusual customer needs or requirements. We could use Zara as an example of that because those are closer to unique, but I'm going to replace that. I'm going to change the slide actually. That's not a good example. Zara is not the best example for engineered to order. Engineered to order means things like a bridge. It could be a custom home. And it means that the customization is from the very beginning at the engineering level, and it's to meet a very unique customer need. Zara doesn't quite drop in there because it's still mass produced, even though it is a form of mass customization. It's really not engineered to order. So my apologies, ignore that Zara, replace it with a bridge or a home. So when does the customization occur? I like this picture because I think it's good to help us understand what we're talking about when we say timing of when and where in the supply chain. So engineered to order, that custom home or bridge, way back here in the design phase. We're doing custom work. Then we're sourcing materials, we're fabricating, assembling, and there isn't a lot of distribution if it's a bridge, but in some design areas it is built to order from the engineering level. The make to order would be the Dell computer, right? So we've got some standard designs, we've got standard sourcing, but during our assembly process we configure in a way that responds to a unique order. So that's make to order. Assemble to order, and be careful you don't confuse these terms because it would be easy to think of Dell as assembling to order, right? So I'm not real happy with the way these terms are laid out, but I'm not going to rewrite the book myself. Okay, so assemble to order is referring to that t-shirt, that white t-shirt that left the plant as a standard part, but is being customized at its very final step to take on some colors or logos or personality that is unique to the customer. Make to stock could be that same t-shirt, but going to Costco or Sears or your clothing store in a bag, and it's still white, right? Make to stock, or the toothpaste we talked about, and food products and so forth. So just remember these terms, and definitely don't get confused between make to order and assemble to order. Be real clear on which is which there, so you don't miss that question on an exam. So there is a law of variability, and that is that the greater the random variability, either demanded of the process or inherent in the process or in the items process, the less productive that process would be. And you should remember that. It's really another way of saying complexity drives cost and risk. And the more randomness that we have, then the less productivity we're going to have. So with customization, you should remember that when customization occurs early in the supply chain, that we will have flexibility in response to unique customer needs at the greater level. So the earlier we customize, the more responsive we are to those unique customer needs. But lead times to the customer will be longer, they will wait, and products will tend to be more costly. So think about that custom home versus a home that maybe only offered you which color floors, which carpet do you want, which doors and windows, instead of custom from the ground up. And that should make sense to you. And of course, products will tend to be more costly. Just drop back in that custom home versus the spec home or the almost spec home, right? Any of those three, and you can envision the timing and the cost implications of it. You could also look at the example of the t-shirt. So the t-shirt at Costco that's in its standard white pack versus the t-shirt that needed to still be dyed and stitched and logoed and have that extra value added step. It takes more time, it adds more cost. When customization occurs late in the supply chain, flexibility in response to customer needs will be limited. There's only so much we can do once we're near the point of delivery. All right, like with the t-shirt, we can add some colors and logos, but we aren't going to make a completely unique design out of the shirt itself. It's already at a size and stitch and largely manufactured. And products will tend to be less costly. So be real clear about these relationships of flexibility, lead time, and cost, and the inverse relationship they have with customization. So in summary, there's 5 classic approaches to those manufacturing processes and the layout, and the best solution depends on the unique situation for a particular firm at a particular time in what the best approach might be. Usually there's some blurring between the lines and mixing between the lines and not just black and white situations occurring. Customization can occur early or late in the supply chain, and remember that it has a large impact on the responsiveness to customer needs, the cost, and the lead times. That ends our discussion for Lecture 3A.